Alright, so after collecting all the data, we're going to analyze it with Excel. Because we know after collecting all the measurements, we want to put into this equation to get a C, the height of center of gravity. And it'll be super hard to calculate, not super hard, but it'll take you a lot of time to calculate it by hand. So I'm going to demonstrate how the data look like and how I'm going to calculate it with Excel. So let's take a look at the data. So this data is from last semester with all the measurements from all the students. So we separated with gender to make the data analysis easier. So here is the gender for females. We got body mass, the height, scale reading with arms by side, and scale reading with arms overhead. So we're going to calculate the height of center of gravity with arms by side and with arms overhead. And we're going to compare the gender differences. So we got female here, and also we got male here. You can see there's we got a lot of more females than males. Okay, so for the demonstration, I'm going to just demonstrate by the males data, and you're going to apply the same knowledge to all the females and get a final result. So the first thing, the link to this spreadsheet is provided, and I don't want you to change any number on it, so please just copy and paste it to your own Excel. Let's do this. Copy and go to my Excel. Going to open a new spreadsheet here. Okay, so let's take a look at sorry, it's a little bit small. Let's take a look at the steps. How do we implement a equation into Excel? So there are several steps. The first step, type in the function, and then calculate the first data set, double click the black cross, and enjoy the magic. So let's see how the magic look like. For example, this is just for example, for a demonstration. So say I want to calculate height multiplied by 2. I want to see the height multiplied by 2 for all the subjects here. So the first thing is to type a equal sign. You can see equal sign here, and then identify 2 multiplied by height. So we're using the first block C3 here, and click enter. We got 3.708. Okay, so that's for the first data set. Second step is to double click. When you move your cursor around, you can see a black cross here. Just double click it. Oh no, it's not working on my computer. So then if it doesn't work, then you can still drag it to the end. So that'll calculate all the data for you. So for example, this is for C3 times 2, and this is for C4 times 2. This is for C5 times 2. Alright, so that's how we calculate one data and apply the same equation to all the column. I'm going to delete this. That's just for demonstration. So let's do our data analysis with the equation. How does the equation look like? It's C is what we want to get, is Fs times 2L minus Wb times L divided by W. So let's do it. Okay, so we calculate C. And how do we calculate C? What is Fs? Fs is scale reading. So for example, we want to calculate C with arms by side. I want to calculate C with arms by side. So Fs will be scale reading, and scale reading with arms by side would be here, D3. So first thing, equal sign, D3. And then 2L. 2L is the whole board length, which is 2.44 meters times 2.44 meters. And then minus WB. What is WB? The weight of the board, which is 52.6. 52.6 times L. What is L? L, we know 2L is the board length, right? So L will be half of it. That'll be 1.22. And the whole thing, parenthesis, divide by W. What is W? Body weight. So the varies among subjects. Body weight would be column B, right here, B3. So we got B3. And click enter. We got it. 1.04. Does that make sense? We know we're using meters right here, right? Because we got 2.44 meters. So we're using meters as a unit for length. And 1.04 meters will be about 100 centimeter, of course. So and this people is 1.854 meters high. So it's about half of its body height, or around the middle of the body height. So it makes sense. And let's double click. No, this still doesn't work. So let's drag the black cross to see the magic happen. Alright, so that's what you see. The height of center of gravity for each subject when lying on a board with arms by side. Alright, so that's the C. But actually you can see the C varies kind of a lot, right? Because people got different height. Like we got higher people and we got a little bit shorter people like me. So the varies from 1.15 to 0.9. And of course, a higher people will have a higher absolute height of center of gravity. But we want to see the relative height of the center of gravity. So we want to see the percentage center of height. Like how much percent of the height is the height of center of gravity. Okay, so how do we calculate it? We're going to use this value, the C, divided by the total body height. So that'll be the C divided by body height. You want a percentage, so we got times 100. So how do we do it? First will be the equal sign, and C will be G3 divided by H will be C3. And the whole thing will be multiplied by 100. So you got 56, which is about 56%, about 50%, right? And then we drag it down. So you can see it's all around like 55% of the height, which confirms our hypothesis. So that's all you need to implement equation into this data set and calculate the center of gravity height. And that's just for arms by side. So you're going to do the same thing for arms overhead. Alright, so that's all you need for the assignment. And what if I want to see the average percentage center of gravity height? So let's do another thing. That's to be equal average, and you select from H3 to H11. So that's the average of everybody. Click enter. The average will be 56%. Okay, so that's how you get an average. And so you need all the procedures to answer the questions in the assignment. That's about it, and enjoy the magics.